Dear students, we are discussing time series forecasting techniques. In the previous lecture, I have explained about various patterns in the time series data. Those patterns are used to select appropriate forecasting techniques. In this lecture, I am going to discuss about measures of forecasting accuracy. These measures also used to select appropriate forecasting technique. So, the agenda for this lecture is, first I will explain what is forecasting accuracy, then I am going to discuss about various forecasting errors. So, first I will talk about what is error, then I will talk about mean forecast error, then mean absolute error, then mean squared error, then mean absolute percentage error. Later I will compare two forecasting techniques. Based on their accuracy level, we can recommend which forecasting techniques is more accurate. The first forecasting techniques which I am going to explain is called naive forecasting method. So, in this lecture, we begin by developing forecast for the gasoline time series shown in table using the simplest of all the forecasting methods. That is an approach that uses the most recent week's sales volume as the forecast for the next week. Suppose, look at the table, there is a 12 weeks is given, week 1 sales is given 17,000 gallons, these values are in terms of 1000. Okay. See, first year we cannot forecast it. See, second year forecast is nothing but this value, the previous year actual values. For third year, it is the second year actual value. For the fourth year, it is the third year actual value. Okay. So, this type of forecasting technique is called naive forecasting method. Next, we use 21. The actual values of sales in the week 2 is 21 as the forecast for week 3 and so on. So, what is happening? The actual value is 21. So, this will be the forecasted value for week 3. So, the actual value of week 3 will be the forecasted value for the week 4. The forecast obtained for the historical data using this method are shown in the table in the column labeled forecast. So, here I have shown everything. Because of its simplicity, this method is often referred to as a naive forecasting method. Now, I am going to discuss about measures of forecast accuracy. We have forecasted by using naive forecasting method. How accurate are the forecast obtained using this naive forecasting method? To answer this question, we will introduce several measures of forecast accuracy. These measures are used to determine how well a particular forecasting method is able to reproduce the time series data that are already available. By selecting the method that is most accurate for the data already known, we hope to increase the likelihood that we will obtain more accurate forecast for our future time period. The first measure is forecast error. I am going to start from the what is error. The key concept associated with measuring forecast accuracy is forecast error. If we denote yt and y hat t as the actual and forecasted values of the time series for period t respectively, the forecasting error for the period t is error Et equal to actual data minus predicted data, actual minus or forecasted data. That is, the forecast error for time period t is the difference between actual and the forecasted values for period t. Now, in this table, I am going to explain what is the forecast error. Look at the value 4. How we got the 4? Actual is 21 for week 2, the forecasted value is 17. So, 21 minus 17 is 4, 4 is the forecast error. See this, 21 minus 14 equal to 4. Here what is the meaning of positive and negative forecast error? Assume that I have data like this, suppose I have data like this, suppose I have forecasted like this. So, here this error is positive error. So, what has happened? If the error term is positive, the forecasting method which I have used underestimated the actual value. If the forecasting error is negative, we have overestimated the actual value. That is the meaning of positive and negative forecast error. That I will explain with the help of this table. The fact that the forecast error is positive indicate in week 2, you see that in week 2 the forecast method underestimated the actual values of the sales. Actually it is a 21, but we forecasted 17. So, the difference is forecast error. Next we see the 19 and 21. Actual is 19, but we have forecasted as a 21. So, we have overestimated, that is why we are getting negative error. In this case, the negative forecast error indicate that the forecast overestimated the actual value for the week 3. See, we have overestimated. Thus, the forecast error may be positive or negative depending on whether the forecast is too low or forecast is too high. A complete summary of the forecast error for this naive forecasting method is shown in the column labeled forecast error. Here I have shown the all forecast error. It is important to note that because we are using the past value of the time series to produce a forecast for period T, we do not have sufficient data to produce a naive forecast for the first week of this time series. See that here we are not able to forecast because we do not have the actual data there. So, there will not be any error, not error. So, we cannot find out forecast error for week 1. Now, the first measures of forecast is mean forecast error. A simple measure of forecast accuracy is mean or average of the forecast error. If we have n periods in our time series and k is number of periods at the beginning of the time series for which we cannot produce a naive forecast, that is the k. In our problem k equal to 1, because for the first data set we cannot forecast. For first week data we are not able to forecast. So, mean forecast error MFE is sigma of t equal to k plus 1, the value of k equal to 1, because for first data one data set we do not have the value. So, we have to start from the second week to the 12th week, we have to add all the error divided by n minus k. So, we have to divide by 11. So, that will the answer will be mean forecast error. Table shows that the sum of the forecast error for the gasoline sales time series is 5. See, when you add this, when you add the forecast error, we are getting sum equal to 5. So, as per our formula, sum divided by number of data, here number of data is 11 because we have forecast only for the 11 weeks. For first week we are not having. So, when you divide it, we are getting the value 0.45. Because we do not have sufficient data to produce a naive forecast for the first week of this time series, we must adjust our calculations in both numerator and the denominator accordingly. The second type of measures of forecast is mean forecast error. This is common in forecasting. We often use k past periods from the time series to produce forecast and so we frequently cannot produce forecast for the first k period. So, the formula is sum the error divided by n minus k. So, the answer is 0.45. The summation in the numerator starts at the first value of t for which we have produced a forecast. So, we begin the summation t equal to k plus 1. So, we have to start from the second week onwards. So, because the value of k equal to 1. The denominator, which is the number of periods in our time series for which we are able to produce a forecast. So, out of 12 we are able to produce for 11 weeks. So, it is 12 minus 1, this will be 11, that is why I divided by 11, here 5 divided by 11, and the 5 we have added only from the second week onwards. In the gasoline example, although time series consists of 12 values, to compute the mean error, we divided the sum of the forecast error by 11 because there are only 11 forecast errors. We cannot generate forecast sales for the first week using this naive forecasting method. Also note that in gasoline time series, the data which is given on the right hand side, the mean forecast error is positive 0.4.5, which implies that the method is generally under forecasting. As I told you, when we can get the positive error, suppose values like this. So, this is your positive error. So, what you have done, we have under forecasting, under forecasted. In other words, the observed value tend to be greater. So, this point is above than the forecasted values. Because positive and negative forecast error tend to offset one another, the mean error is likely to be small. Thus, the mean error is not a very useful measure of forecast accuracy. So, this method is not a very useful measures of forecast accuracy. So, what we are going to do? We are going to use another technique called mean absolute error. The mean absolute error, denoted by MAE, is a measure of forecast accuracy that avoids the problem of positive and negative forecast error offsetting one another. As you might expect, given its name, mean absolute error is the average of absolute values of the forecast error. So, what you have done? We have taken absolute value of the error, only for that we are adding. Otherwise, when you add the error, there is a possibility it may become 0 also. This is also referred to as the mean absolute deviation, MAD. The table shows sum of the absolute values of the forecast error is 41. You see that? So, first I have found the forecast error. So, wherever negative I have converted into positive, then when you add it, we are getting 41. So, when you divide 41 by 11, you will get 3.73. The next measure is mean squared error. Another measures that avoid the problem of positive and negative error offsetting each other is obtained by computing the average of squared forecast error. Previously, we did not square the error, simply we have added the error, then we have divided by number of periods. Here it is 11, because only for 11 periods we are having the forecasting. So, this measures of forecast accuracy referred to as mean squared error. There is a reason why we are squaring this error. Suppose if the deviation is say 0.5, right, when you square it, it will become 0.25. If the error is 5, when you square it, it is 25. So, what is the advantage of squaring is, it amplifies if there is more deviations. If there is a less deviation, the amplification is very less. That is why in the variance formula also, you might recollect, the variance formula is sigma of x minus x bar, that is nothing but error square divided by n minus 1. the purpose of squaring is to give higher penalty for higher error for larger deviation, lesser penalty for the smaller error or smaller deviation. So, here I have explained how to find out mean squared error. So, what I have done, first forecast error, then I have squared the error, then I have summed, it is 179. So, there are 11 data set, so it is 16.27. So, the mean squared error is 16.27. The size of mean absolute error and mean squared error depends upon the scale of the data. Now, I am going to introduce another measures of forecasting accuracy, that is called mean absolute percentage error. Before that, I will explain why this measures of this mean absolute percentage error measure is required. The reason is, the previously we have used mean absolute error and mean squared error. These depends upon the scale of the data. As a result, it is difficult to make comparison for different time interval. For example, comparing a method of forecasting monthly gasoline sales to a method of forecasting weekly sales, that is not possible. So, this comparison is not possible by using your mean absolute error and mean squared error. The another example is comparison across different time series, such as monthly sales of gasoline and monthly sales of oil filter, because these are two different products. This comparison also not possible. To overcome this drawbacks, we are going to introduce another measures of forecasting accuracy, that is called mean absolute percentage error. To make comparisons such as these, we need to work with relative or percentage error measures. The mean absolute percentage error, denoted by MAPE, is such a measure. To compute mean absolute percentage error, we must compute the percentage error of each forecast, that is error for time t divided by actual data, then multiplied by 100, that is the percentage error for each forecast. For example, the percentage error corresponding to the forecast of 17 in a week 2 is computed by dividing the forecast error week 2 by the actual value in week 2 and multiplying by 100. For week 2, the percentage error is computed as follows. So, percentage error for week 2 equal to error 2 upon the actual value for week 2. The error is 4, the actual value is 21, multiply by 100, you will be getting 19.05 percentage. I will show you in the next table. See this. The error is 4, the actual value is 21. So, 4 upon 21 multiplied by 100, you will be getting 19.04 percentage. Like this, we can do for all 12 weeks. Thus, the forecast error for week 2 is 19.05 percentage, this one. Similarly, for next one, minus 2 upon 19, you will be getting minus 10.52 percentage. So, a complete summary of the percentage errors is shown in the table in the column labeled percentage error here I have provided. In the next column, we show the absolute value of percentage error. So, here minus 10.52, I have taken only the positive value. Finally, we divide by number of forecast error, that is your 11. So, then you will get mean absolute percentage error. This table shows that sum of absolute values of percentage error is 211.69 here. When you divide by 11, you are getting 19.24 percentage. In summary, using the naive most recent observation forecasting method, we obtain the following measures of forecast accuracy. Mean absolute error is 3.73, mean squared error is 16.27, mean absolute percentage error is 19.24 percentage. These measures of forecast accuracy simply measures how well the forecasting method is able to forecast historical values of the time series. Now, suppose you want to forecast sales for a future time period such as week 13, for example, here week 13. In this case, the forecast for week 13 is 22 because we are using the naive method 22. So, the actual value of the time series in week 12, values is 22. Is this an accurate estimate of sales for week 13? Is it correct? Is it accurate? Unfortunately, there is no way to address the issue of accuracy associated with forecast of future time periods. However, if we select a forecasting method that works well for the historical data and we have a reason to believe the historical pattern will continue into the future, we should obtain forecast that will ultimately be shown to be accurate. So, we have forecasted for week 13, the forecasted value is 22. There is no guarantee this pattern will be repeated in future also. If you believe that the same pattern of sales for first 12 weeks also will be replicated in future, then we can use this naive forecasting method. Now, I am going to take another type of forecasting method, that is average of past values. So, we begin by developing a forecast for week 2. Since there is only one historical value available prior to week 2 here, only one historical data, the forecast for week 2 is 17,000 gallons of gasoline. To compute the forecast for week 3, we take the average of the sales for week 1 and 2. So, that is 17 plus 21 upon 2, it is 19. So, the forecasted value for week 3 is 19. Similarly, the forecast for week 4, right. So, the week 4, right, we have to find out the forecast value. So, what we have to do? We have to average these 3, 17 plus 21 plus 19 upon 3, we are getting 19. So, this 19 will be the forecasted value for week 4. The forecast obtained using this method for the gasoline time series is shown in this table in the column labeled forecast. By using the forecasting method called average of past values, I have found mean absolute error. Look at the table. This I have solved in the Excel. At the end of this lecture, I will show you the Excel. So, the time series is there, time series values. I have found the forecast by having average of the previous values. I found the forecasting error, then I found the absolute value of forecast error, then I found the squared forecast error, then I found the percentage error. Percentage error is error upon the actual value, then I found the mean absolute percentage error. So, by using similarly I found the total also. So, mean absolute error is 26.81 upon 11, you will get 2.43. Mean squared error is 89.07 upon 11, you will get 8.07. So, mean absolute percentage error is 141.34 upon 11, you will get 12.84. So, these forecasting measures are for different type of forecasting technique, that is average of past values. Now, we have to compare which method is most accurate. The first method we used naive one, the second forecasting method which we used average of past values. Look at the different measures of forecast accuracy. When you compare mean absolute error, this is 3.72, this is only 2.43. So, this is better. Mean squared error, this is 16.27, this is 8.09, again the average of past value, this method is better. For mean absolute percentage error, this is 19.24, here it is only 12.84. So, when we compare, even though the data sets are different, the second method, that is average of past values method, is providing accurate forecast than the naive method. Dear students, now I am going to explain how to use spreadsheet for forecasting using the naive method and using the average of past value method. I have 12 weeks sales, the time series values are given 17, 21, 29, 23 and so on. So, if you use naive method, it is 17 because the week 2 forecast is the week 1 actual sales, then 21 is week 2 actual sales is week 3 forecasted values. Okay. Then I found the error. We know what is the error? Actual value minus forecasted value. So, we got 21 minus 17. So, I have dragged it, 21 minus 17 is 4, then 19 minus 21 is minus 2 and so on. Then I used in Excel, there is option absolute ABS, that will provide only the absolute value, that is the positive value. Okay. Then I have squared that, then I found the percentage of the error upon actual value. For example, D5 divided by B5, then percentage error, then I found the using absolute function, I found absolute value for percentage error. Here I found the total because I want to know the average. So, we know n is 11. So, mean absolute error is the total value divided by 11, then mean squared error, for mean squared is 179 divided by 11. So, you are getting 16.27, mean absolute percentage error 211.68 upon 11, you will get this value. Similarly, for the second forecasting method, that is the average of the previous values. For first week there is no forecast, for the second week you see that there is only one value 17 upon 117. For the third week I have added 17 plus 21 upon 2, that is 19. For the fourth week I have found the average of the previous week actual sales, that is 17, 21, 19. So, I got 19. Then as usual I found the error, actual minus forecasted value, then I found the absolute error, then the squared error, then percentage error, then I found absolute value of percentage error, then I have done the sum, then by using that sum and the number of data set is 11 here also. So, I found mean absolute error and mean squared error and mean absolute percentage error. Then I have compared which method is most accurate method. So, we are concluding that the averaging the past values for forecasting the next period is the best way of forecasting. There is a more accurate method when compared to naive method. Dear students, in this lecture I have discussed about measures of forecasting accuracy. What are the measures I have discussed? First I have talked about error, then mean forecast error, mean absolute error, mean squared error and finally mean absolute percentage error. These forecasting error will help to select appropriate forecasting techniques. Thank you.